Hello all, in this video I'm going to discuss AVL tree insertion. So here we are going to construct AVL tree for the following data. These are the data given. Step by step we are going to perform the insertion operation. So after every insertion, after inserting each and every node, we should find the balancing factor. Only if the node is balanced, if the tree is balanced, we are going to proceed further. If it is not balanced, we are supposed to make it balanced, and then only we can go for inserting the next data element, right? The very first data element here is 10, right? We are just going to insert the node 10. Now the balancing, there is only one node here in the tree, which is 10. The balancing factor is there is no left subtree as well as there is no right subtree, so the balancing factor is going to be 0, which is balanced. Why? Because the balancing factor should be either -1 or 0 or 1, right? Only if these three values are there means we can say that the tree is balanced, otherwise it is not balanced. We have inserted 10 successfully. Now the next data element is going to be 15, right? So already 10 was here. Since it is going to be the binary search tree, because the very first constraint is it should be binary search tree, then only we can make it balanced, right? So 15, since the 15 is greater than the root node 10, it will fall under the right hand side of the node 10. When we calculate the balancing factor, left subtree minus right subtree, it is going to be 0, and here the height of left subtree is 0 and the height of right subtree for the 10 is going to be 1, so 0 minus 1 1, which is balanced again. We can proceed further. The next data element which we are going to insert is 9. The next is 9. 9 is lesser than the root node 10, so it will fall over here. When we calculate the balancing factor, height of left minus height of right subtree is 0. Here also it is 0. The height of left subtree is 1 and the height of right subtree is 1, which is 0 again. Again it is balanced only, we can proceed further. Next is, we are going to insert the data element 4. After inserting each and every node, we are supposed to calculate balancing factor for all the nodes. Now the data element which we want to insert in the tree is 4. So since 4 is lesser than the root node, it will fall under the left hand side. Again there is a 9. So again 4 is lesser than 9, so 4 will come here. When we calculate the balancing factor, 0 minus 0 0, 1 minus 0 which is 1, again 0 minus 0 0. Here the height of left is 2 and the height of right is 1, which is 1. Again the tree is balanced. The next data element which we are going to insert is 49. Already there was 10, 9, 15 and 4. Now the new node which we are going to insert is 49, which is coming greater than the root node, so it will fall definitely under the right hand side of 10. So again 15, where 15 is lesser than the node which we are going to insert, so 49 will fall over here, right? When we calculate the balancing factor, again 0 here, again 0, 1 minus 0 which is 1, 0 minus 1, so it will be minus 1. So height of left minus height of right is going to be 2 2, which is 0. Again the tree is balanced. You don't need to do any rotation over here to make it balanced because already it is balanced. Then now the next data element which you are going to insert is 3. Already there was 10, 9, 15 and 4 here and 49 here. Now the new node which we are going to insert is 3, right? So 3, which will definitely fall under the left subtree only. Again 9, when we compare, again it is lesser, left hand side only. Again 4 is there, so the right position is here. It will act as the left child of the node 4, right? So when we check now, the balancing factor is 0. Here also it is 0. 1 minus 0 which is 1. Then again the height of left subtree is going to be 1 2, right? 2 minus 0 which is 2, which is not balanced only. Since it is not balanced, before you proceed further, you are supposed to make it balanced, right? So which is not balanced? This node is not balanced, right? So you need to consider, you need to make it balanced. You just apply rotation over these 3 nodes. From the node which is not balanced, you are supposed to consider 3 nodes, right? So which rotation you are supposed to apply? When you check here, this is left and this is also left, so you are supposed to apply left rotation. After applying left rotation, so 10 will remain in the same place, 15 also will remain in the same place, and again 14 will remain in the same place. We are applying the rotation only over these 3 nodes only, right? So when we make it balanced, when we perform left rotation over these nodes, our tree will become like this. You pull 9 down, so finally it will be like this, right? So we are going to attach it over here. 4 will come here, and then 3 will be here, and 9 will be here. When you calculate the balancing factor, 0, 0, here also 0, here also 0, here it would be -1, and here 2 minus 2, it is going to be 0, which is balanced only, right? Now, the next node which you are going to insert is 11. The actual tree was 10, 4, 15, 3, 9. Now the new node which you are going to insert here is the data element 11 here, right? So the right place for, sorry, I forgot to include this 49. So right place for including 11 is here, right? When we check the balancing factor, yes, it is balanced only. Everywhere we get 0. It is balanced. The next step is, the next data element which we are going to insert is 7, right? So the right place for 7 is here, left child node for the node 9, right? When we calculate the balancing factor, 0, 1 minus 0 which is 1, 0, 1 minus 2 which is -1, 0, 0, 0. Then the height of left subtree is 1, 2, 3. 3 minus the right subtree is 1, 2. 3 minus 2, 1, which is balanced again. The next data element which you are going to insert is 8. Now 8 we are going to insert. So 8 will fall over here. After inserting each and every node, we are supposed to calculate the balancing factor. For 11 it is 0, for 49 it is 0, 15 also it is 0, for 8 it is 0, for 7 0 minus 1 which is -1, for 9 2 minus 0 which is 2. It is not balanced only. When it is not balanced, we are supposed to make it balanced, right? So from the node which is not balanced, the node which is not balanced is 9. So from the node which is not balanced, we are supposed to take 2 other nodes also from the node which is not balanced. So we are supposed to apply rotation over these 3 nodes only. Which particular rotation you will apply? This is 7 is acting as the left child node for the node for the parent node 9, and 8 is acting as the right node for the node 7, right? So now we are supposed to apply left right rotation, right? So rotation over these 3 nodes only, 9, 7 and 8, right? So when we perform left right rotation, the very first step is we are supposed to flip it, right? So when you flip it, 9 will come here, 8 will be just pulled up over here to this position, and the 7 will go down. Now again you are supposed to perform left rotation. Left means just pulling the 9 down. So 8, 7 and 9, right? So after applying the rotations over 9, 7 and 8, this is how your final tree will be, right? So now your final, after applying the rotation, this is going to be your final tree. 10. You should not touch the other elements other than these three data elements. You're not supposed to touch any other positions. So 15 will remain in the same position, 11 also, as well as 14 and also will remain in the same position. So after applying the rotation over these three nodes, this is your final result. Attach it here. Eight, 7, 9. Right? Now when we calculate the balancing factor, 0, 0, 0, here also 0, 1 minus 2 which is minus 1, 0, 0, 0, and the height of left is 3, 3 minus height of right is 2 which is 1, it is balanced, right? The next data element which we are going to insert is after 8, it is 6. We are going to insert the data element 6. This was the actual tree. 4, 15, 3, 8, 11, 49, 7, 9. Now the new data element which we are going to insert is going to be 6, right? The right place for the data element 6 is here. When we calculate the balancing factor, 0, here it is 1 minus 0, 1, here it is 0, 2 minus 1, 1, 0, then the height of left subtree is 1, the height of right subtree is 1, 2, 3, 1 minus 3 which is 2, 0, 0, 0, right? So here this node is not balanced, right? The node 4 is not balanced because the balancing factor which we are getting is 2, which means the tree is not balanced. So which node is exactly not balanced means 4, right? So from the node which is not balanced, three nodes. You can ask me like why we have considered these three and why not these three, you can ask. The reason why I have considered only 4, 8 and 7 means through this path only I have inserted the new element. So you have to choose the path where you have inserted the new data element. Since I have inserted 6 here, I am supposed to follow this path only. That's why I am choosing 4, 8, 7 instead of choosing 4, 8, 9, right? So these three are not balanced, right? 4, we are supposed to apply rotations, we are supposed to apply rotations on these three data elements. Which rotation we will apply? Right, and this is left. So we are supposed to apply left right rotations, right? So 2 rotations totally we need to perform. The very first thing is pulling the 8 down, right? So 4, after flipping it, 7 will be here and 8 will be there. Then again right rotation you need to perform. So when you pull 4 down, 7, 4 and 8, right? So after applying the rotations, this is how a tree will be. So now you attach this in the main tree. 10 will remain in the same position and 15 also will remain in the same position, 11 and 49 as well. Now instead of 4, 8, like instead of maintaining this tree, since it is not balanced, we have made it balanced. So we are supposed to write 7 here, 4 and 8 over here. Other than this, 3 more nodes are left out here. 3 was acting as the left node for the node 4, right? So 3 will remain in the same position. Then again 6 was acting as a left node for the node 7, right? So left node for the node 7, so here it will be 6 is acting as a left node for, like 6 is falling under the left hand side of the node 7, and one more node is left out which is 9. So 9 was acting as the right node for the node 8, so 9 will come here. Now when we calculate the balancing factor, 0, 0, 0, here again it is 0, here 0 minus 1, 0, 0, 0, the height 2 minus 2, Then again height of left is 1, 2, 3. The height of right is 1, 2, which is 1. Again the tree is balanced. The next node which we are going to insert here is 51. 51 we are going to insert. 10, 7, 15, 4, 8, 11, 49, 3, 6, 9. Now the new node which we are going to insert is 51, the correct position according to binary search tree. The correct position for the node 51 is right hand side, like it will fall under the right hand side of the node 49. It is going to act as the right node for the node 49, right? When we calculate the balancing factor, 0, 0, 0, 0, minus 1, 0, here 0, minus 1, 0, 1 minus 2, which is minus 1 again, and again here 3 minus 3, which is 0. Again it is balanced, right? The next node, the final data element which you are going to insert in the tree is 60, right? So the right position for inserting the node 60 is going to be here. Again, right child for the node 51, right? Now when we calculate the balancing factor again, when we calculate the balancing factor, for 60 it is 0, for 51 it is going to be 0 minus 1, which is minus 1, and for 49 0 minus 2, which is minus 2. Again the node 49 is not balanced. We are supposed to make it balanced. The node 49 is not balanced, so we are supposed to apply rotations on these three nodes, right? So which rotation we will apply? Left, left. So we are supposed to perform left rotation here. After performing the left rotation, this is how our tree will be. So rotations can be performed over only 3 nodes, not more than 3 nodes. So 7, 15, rest remaining all the nodes will be in the same position. 6, and here it is 9, right? Again 11. After applying the left rotation, this will be pulled down. So this is how it will be: 51, 49 and 60, right? So 51, 49, 60. Now we calculate the balancing factor: 0, 0, 0, 0, minus 1, 0, 0, 0, 0, 1 minus 2, which is minus 1, and here 1, 2, 3, minus 1, 2, 2, 3, 0, which is balanced. So this is how we are supposed to perform insertion in the AVL tree, and also we have to calculate the balancing factor after inserting new node every time. So only if it is balanced we are supposed to proceed further, otherwise we are supposed to make it balanced and then only we can start inserting the new node, the remaining nodes. Thank you.